All right, hello everyone. This is Seth Grimes. I'm the TEDCO AI Roundtable organizer. For those of you who don't know, TEDCO is the Maryland Technology Development Corporation. And give me a second. Gotta disable the audio on my secondary device. There we go. Yeah, so TEDCO is the Maryland Technology Development Corporation. They have engaged me about a year and a half ago to conduct an AI roundtable with startups and others in the Maryland AI world, artificial intelligence world. And we had in-person discussions through February, and then we went online. And going online and figured, why not open these things up to participants from the Baltimore Tech Meetup and the Maryland AI Meetup, so that others can join in the conversation, because these are topics of general issue. So the roundtables are not like the other Maryland AI and Baltimore Tech Meetups, which are focused on presentations, then Q&A and discussion. The roundtables are, the aim is to be primarily discussion. So we do invite guests in to participate. So let me show you who I am and where I can be found by email and on Twitter. And then in addition, we are recording this session, and I will post the recording to a Maryland AI YouTube channel so that others can view it. You can freely share that, but be aware that this conversation is being recorded. And if you did not come through the Maryland AI meetup, there's the address there. If you're in the Baltimore Tech meetup, well, I don't list that, but that's an equivalent good way to come in. So for notices of programs, in addition to the roundtable ones, I hope this isn't too confusing, you should join the meetup. So we have at this moment 32 participants, in addition to a guest today, who is George Soto, who has a good experience in the cloud, AI, and machine learning world. So I've invited him in as someone who has some expertise in the topic that I personally don't have. I have a great familiarity with it. The way we're going to structure this is that I'm going to say a few words about cloud AI and machine learning, and then introduce George, who will show some slides. I see that some of you are looking at his slides already. I'm going to give you the link for them, because why not? Because he was happy to share them. And then after that, I'm going to call on the roundtable regulars to speak if they wish to introduce what they are doing briefly by way of cloud AI and machine learning, what platforms they are using, what tool sets, whether they're using it for data science or for product development or something else entirely, because this is supposed to be a discussion with an exchange of experiences and views. And I'll hope that George will help me interrogate the people who are participating to engage with them and learn, and that you will engage with one another. So the topic today is AI, machine learning, and on the cloud. We've had the possibility of doing those functions on an installed basis, not a cloud basis, for many years, of course, with a variety of workbenches, but the cloud overtakes everything, some things more slowly than others. For instance, if you're working in a regulated industry where there are concerns about putting the data in the cloud, well, there are solutions for that, but never everyone is as fast to use them. Of course, the principal cloud platform in general and for AI and machine learning is Amazon Web Services. But there are others out there that are very attractive. There's Google Cloud, there's Microsoft Azure. For that matter, there's Alibaba, maybe less used in the United States. There's IBM has a cloud platform with Watson and so on. Each of these has advantages in terms of the toolkits available and the services that can include security, networking, tools, the whole variety of things. They can include specialized models for natural language processing, for text to speech, for image recognition, all sorts of things. So I hope that we'll be able to get into advantages and disadvantages. Once again, share views and experiences in a friendly context and learn from one another. But the way we're going to start off is we're going to have George give a presentation. So George, I've unmuted you and you can start your video. I'm going to stop my share of this slide and you can start a share of your own presentation materials. I very much appreciate George's joining us today. As I said, he has some good expertise and experience in cloud, AI, and machine learning. I give very, very brief introductions because I hate when I go to a conference or a program like this and have someone read something that's not firsthand experience or anything like that. So George, I'll invite you to start off by introducing yourself, what you do, who you do it for, anything you wish to say. I'm going to stop my video and have you go ahead. Thanks.
Sure. Thank you, Seth, and thank you everyone for joining us today. My name is George Soto. I'm a data scientist and data engineer at a nonprofit in DC called Share Our Strength. We're mainly known by a campaign called Knock It Hungry, where we use fundraising, data, and technology to fight childhood hunger. We do that through various partnerships and different fundraisers. And the goal is, again, to get all that money that we collect for fundraising and give it to schools so they can implement breakfast, lunch, and summer programs. With this outbreak, as you can imagine, things have been a little bit challenging. So I'm happy towards the end to talk a little bit about how we, as a nonprofit, have adopted our strategy to serve better families in need. After work, I also wear another hat as a ongoing learner, as well as a practitioner in AI and deep learning. If you join us from our secondary meetup, Deep Learning Adventures, welcome as well. That's another meetup that I organize in collaboration with David and Robert, and we take their deeper dive in some of the technologies that you're going to hear today and some of the challenges. So thanks again, Seth, for inviting me. I put a few slides together just to kick us off, and again, I have a few links here if you want to connect with me on LinkedIn and so forth. So when I think about cloud and AI, like you mentioned, Seth, back in the days, things used to run on-premise. People used to build their models. If you needed more RAM or more CPU or more GPU, you had to buy, you had to install, you had to introduce your own, you have to install your own packages, dependencies, and all that. And as you've seen, for many years now, the cloud is really taking off that infrastructure side of the equation. So now all you really have to do is basically familiarize yourself with the tools and products that each cloud provider offers, and you can utilize them based on your knowledge of software development. So you mentioned some of the players, some of the big companies that, I'm just having some slides here from Google Cloud Platform, from Microsoft Azure, as well as AWS, Amazon Web Services. The way that I really think about this is a spectrum of products and a spectrum of services, and the challenge really is to identify what is the right solution for my challenge, or for my company's or organization challenge, or maybe me as a new learner who really wants to know more about cloud and AI. Where can I start, and where do all these different products fit into the picture? So the way that I see it is, I had the privilege to actually interview Google's AI lead, Lawrence Moroney, a couple of months ago with our Deep Learning Adventures meetup. And what struck me is that why did he create some learning courses on Coursera? And he mentioned that there are about 30 million software developers in the world, but about 300K AI practitioners. That means that people can actually code something, create a model, evaluate it, deploy it in production, and so forth. So you see the highly imbalanced here of AI practitioners and software developers. And he said, our goal is basically to enable and train software developers to become AI practitioners. According to him, the jump shouldn't be that hard, that if we give them the right tools and the right training, they should be able to do that. So thinking of that way, these different platforms offer different solutions, and based on your familiarity with either data science and heavy math and heavy machine learning experience, all the way to somebody who just knows really well programming language, like Python, Java, C++, or maybe just an SQL developer. Based on your experience and expertise, you can find now different solutions that will enable you to run AI models on the cloud. So this image that I took from this link down here from Sarah, she did a really great job of explaining this. But basically, the bottom of the pyramid is open source machine learning frameworks. Like think of like TensorFlow, PyTorch, MXNet, and different open source projects that allow data scientists and machine learning engineers to build something from scratch. So here you have to really be hands-on. You really have to install your packages. You really have to take care of dependencies. You have to keep updating your hardware if needed, and you really have to be familiar with the software library. This ML frameworks also run on the cloud. So if hardware is a limitation for you, then you can also run them on the cloud. You can run basically what is called a deep learning VM image, which is the next building block. So in case you're limited by your infrastructure and you want to scale out based on demand, you can rent basically a virtual machine, a VM, and that will come already pre-installed with all the different applications that you need. So for example, if you're using PyTorch or TensorFlow, you don't have to worry about GPUs and CUDA and all the dependencies and all the software dependencies. The deep learning VM image already comes baked in with those software applications. So at the bottom, we had infrastructure and code. At the second level of deep learning VM images, we have we don't have to worry about so much about infrastructure. Obviously, we have to provision it and maintain it and shut it off when we're done using it. Then the next level up, there are several other services that abstract away basically the AI and in the infrastructure part. So the goal is the higher you go in the pyramid, the less you have to worry about the infrastructure and the maintenance, and the more you can, the easier it is for you as a software developer to come in and contribute. So if you're worried about distributed systems and for example, if you're using the open source project Kubernetes, Google Cloud has this product called Kubeflow where you can deploy your machine program, your machine learning projects there. I haven't personally used this yet, and I'm curious if anybody has seen it. For me, things get really interesting after this level where you have products like AI Platform or BigQuery ML. I'd quickly mention BigQuery ML. It's an interesting project for me, an interesting idea where basically if you're very skilled with SQL, structured query language, and you have a lot of data and you are trying to predict, for example, based on usage history, is a new customer going to buy something from my store, or based on maybe donation history, is a new donor going to give something to my nonprofit organization. So you can create a model in this product called BigQuery ML for GCP specifically as just another enhanced SQL syntax. You can say create a replace model. There are different models that you can explore, like linear regression, classification, k-mean clustering, but all that model is doing is basically being fueled by the data that you have in your backend. And that data could live in the cloud, could live in different cloud solutions. Then on top of that, if you don't want to worry about the model itself, what kind of model should I use? What kind of code should I use? If that's something that is not really of interest to you, the cloud providers also have something called an AutoML. More and more of them are trying to get into this field. To me, that's more of the future of how these tools and toolkits will be utilized. So what that allows you is to choose from a specific set of fields. So if you're working in the computer vision field, in text analytics, NLP, like you mentioned, Seth, or structured data, you can provide your model with the data you have. You can specify what is your target, what are you trying to predict. And the tool itself will identify what is the best model and also what is the best approach to train a model and serve it. Then the very last tip of the iceberg here is the APIs, and all three and all the cloud providers have this building block. This allows you to use AI services as an API. So all you need is an API key, and all you need to know is their documentation. So what that means is that if you have, for example, a computer vision or an NLP problem, and you're trying to do some kind of, let's say, classification, you just have to give your image as an input to the API. You'll run on the cloud, you'll do the inference, it's already pre-trained, he knows it's been trained on a huge data set, and hopefully it can give you back the results that you want. So it's basically AI as a service. I have a couple more slides here on some other examples. How can you deploy something with just from an SQL developer perspective? I find that really interesting. And some other screenshots here from AWS on specific business use cases. For example, if you're working with fraud detection, or if you're working with chatbots and you want to maximize your user engagement, there are specific services within those cloud providers that you can look at. And again, the journey, if you come from a traditional data analyst or data scientist background, the journey is you somehow get access to your data. That's step number one. Usually you have to prepare it, pre-process it, you have to do some kind of discovering, and then you have to really get your hands on the data and try to identify what is the best model that will answer my questions from a business perspective. Once you train that model, you have to test and analyze it, and eventually have to deploy so you can serve your customers later on. And then these are some of the algorithms that the BigQuery ML supports. Again, I mentioned linear regression, time series, deep neural network as well. So a wide range of different services that you can utilize just by knowing basic SQL. So I'll go back to the pyramid and I'll stop here and open up for questions. I know there's a lot of content thrown here, so make sure that there's time for questions.
Yeah, well, let me ask you for the moment, and if people do have questions specifically, you can enter them via the Q&A, and I'll enable you to ask them directly yourself. But you know, there are the leading platforms, Amazon Web Services. How does one choose typically? You know, are some stronger, for instance, in image recognition, in conversational AI, where I would think that the Amazon has the best facilities. How do you make the choice yourself in your own work, and how do you recommend people go about discovering which is the best platform for them?
Yeah. So if you're a new user of AI's products and solution set, then the number thing that you'd look at maybe is cost, and does it answer all the questions that you need? And if so, then the evaluation could be relatively easy. Usually, companies are very well invested in one of these leading providers. So if all your data and infrastructure, for example, is in AWS or Google Cloud, it's a little bit tricky for you to use another cloud provider. You could. There's no harm in it. It's just that it's much easier to use the provider that your data already is hosted on.
I assume that there is very, very limited interoperability, that you should really stick to one or another. You know, even using APIs, trying to use more than one at a time is not a good idea. Is that the case?
Yeah, so in my day-to-day job, I actually use APIs from both. There are strengths and weaknesses, I think, to both. You know, cloud, AWS.
What is your everyday usage?
So for us, a day-to-day job, actually, we utilize more traditional APIs from both providers, like geocoding. We want to make sure that we do locate the different sites that we serve properly. So for that, you know, from just my experience, we found the Google Maps API has better service. We are trying to get into structured data as well as NLP, and for that, both providers have really good performance.
Wait a minute, you've been doing NLP and you're getting into structured data? That's like the reverse of 95% of the world, if not 99%.
I'm exploring both, yeah. To me, most of the data is in structured format for us. I mean, most companies, organizations, again, that's why these, you know, data analysis is taking off, right? That's why this software development and all that, because you have giant tables, they're stored somewhere. All you're trying to do is just basically predict the next record or the next field.
So is your work primarily data science, let's call it, you know, exploratory data analysis, or is it also or operationalized in the sense that you're actually deploying models into production settings? And, you know, of course, then there are people who are building products on top of these platforms.
Yeah, it's a little bit of both, yeah. So I actually do the research, try to identify the model that will best serve our needs. I have access to all the data that I need. And I have a small team around me that once I build the model, deploy it, I go to the next phase where I introduce a new feature or explore a new model. Yeah, but testing is super important because all these models, all they do is they're very specialized, so you need to make sure that you choose the right one and you test it significantly.
Yeah, is it really difficult to I'm wondering about the maintenance situation. For instance, if a new model comes along and you decide you want to replace the one that you've been using, or new features within an existing modeling environment, or maybe you decide you like some other workbench, notebook better than an existing one. There's a constant emergence of new technologies here.
Yeah.
Are some better for that than others? How do you cope with that situation?
Yeah, for me, usually once, let's say you go with a framework, let's say you use one of the deep learning frameworks, for example, TensorFlow, PyTorch. For me, I see a significant boost when the next version of that software is updated. And again, you have to make sure that your code still is operational, and usually you get high performance based compared to the previous version. So for me, that's a bigger jump. But yeah, if for some reason I'm not happy with the performance of one notebook or one model, yeah, definitely exploration is the right approach.
Okay, I did chat, but maybe people didn't see it. I would love to really have a robust discussion here with individuals, number one, talking about their own needs and experiences and all of that kind of stuff. We have 41 people attending, so I can't put you all on screen at one time. So I will do it selectively and ask you to raise your hand using the Zoom raise hand feature, or if that's a problem for you for some reason, you can chat to the panelists. And we do have a question from one person who is Abdullah Al-Houthi, and I am making you, Abdullah, a panelist so that you can ask your question yourself live. You are going to need to unmute, and if you wish to turn your video on.
Is it working? Am I though? Okay, I'm the good person. All right. Okay. Just yeah. So my question was: are models gone from different cloud service providers like Azure interchangeable between models? So, for example, if I train a model on Azure, can I download, save the model, put it into a Google machine, a virtual machine, and have it run the model? It wouldn't be a problem, assuming, like, for example, it's trained on scikit-learn, some like common library.
Yeah.
That's a question.
Yeah, that's a good question. Yeah, if it's a common library, like you mentioned, scikit-learn or TensorFlow or PyTorch, yeah, absolutely. You can explore the model, you can explore the weights as well of the model, and you can import it to any other cloud infrastructure. Where things get a little bit complicated is for some reason you want to change completely training framework. So let's say you want to go, for example, from TensorFlow to PyTorch for some reason. Could be infrastructure, could be cost, could be maybe your new company uses that product, but you have all these tools that you've used in another deep learning framework, for example. There is an open source project that tries to basically store a model in its weights as a interchangeable format. Basically, think of it as like a next version of JSON. So you can export that to that version, and then you can import it to your newer one. And I see a lot of companies have joined this open source project called ONNX, and I've seen Amazon, I've seen Facebook, I've seen Alibaba. I don't think I've seen Google yet, but there's a lot of other companies. Baidu, I think, is there. IBM is there. Having this open source interchangeable model where you can store your data. You can write it in any infrastructure, any framework, but you can store it in a common format.
What's driving that? Is it demand from users, including ones who have a lot of money, that are inducing them to do this because of advantages of one platform over another? They're used for different functions, but you want an ensemble of platforms that will combine the best in class from each one. Is that the situation here? Yeah.
Ensemble model is one example, but also companies realize that this is a collaborative effort. So if you want to really advance AI and ML, it's best if you become collaborative and if you share your models and your weights with other people. So this open source project, I just shared a link on our chat, is trying to bridge that gap.
Okay, so I see ONNX.ai. Yeah, I'll take a look at that. Stephen Milligan, I've put you as a panelist. I see you're unmuted. You have a question, comment? You want to talk about what you're doing?
Yes, I was interested in all the participants. I've run into two things with cloud services that I personally haven't been able to solve. One is with Azure and with AWS. There doesn't seem to be a mechanism for, reducing your model to a map and exporting it to an external device. They just assume that you're always going to run connected to their platform. And I didn't know if anybody had come up with a solution for that. And then the other is if you don't do a bottom-up build of the software, like get a EC2 instance and build it all the way up, I haven't found a way to be able to access the lower layers, like the CUDA and the libraries, which I use to run like the profiler, the Insight Systems profiler, to see how efficient we're able to transfer data and utilize the resources like the GPUs. So I didn't know if anybody had any solutions for those two things.
Yeah, that's a good question. Unfortunately, yeah, once you develop a model, let's say in one of the other platforms apart from the lower level ones, let's say people something on AutoML or like BigQuery ML, unfortunately you don't have access to the underlying libraries and infrastructure. So I don't think I've seen an export capability where you say, okay, I trained it on a large GPU, let me export it. You have to use maybe like a deep learning or like a machine learning VM, train it there where you have the capacity and infrastructure. Somehow you have to shrink it back, right? Because you're using devices on the edge, right, Steven? So somehow you have to shrink that model, or maybe use a model that has way less layers, way less capacity, and way less parameters. Export it as hopefully a file that your model in your GPU can use, and then deploy it there.
Well, you can, yes, and Google supports that because you can compile through TensorFlow Lite, which effectively freezes the model and allows you to do things like the quantization and things that make your model more efficient. Mm-hmm. But the other two, I couldn't find a facility that was the equivalent of the Google model.
Mm-hmm. Yeah, probably still working on it. Yeah, you'll find plus and minuses in all of them. Like if edge devices is your use case, then yeah, you definitely need to do your research and find the provider that best fits your needs.
All right. We had another question from Rahul Geet. Sorry if I didn't get that quite right. Rahul, I'm switching you over to a panelist so that you'll be able to ask your question live. Or make your comment. Yeah, start your video and unmute.
Yeah, hello. So my question was regarding the AutoML part. So what are the current libraries TensorFlow or PyTorch are providing so that we can directly use AutoML part? So I am familiar with one of them, AutoKeras, but I'm trying to explore more. So if you could help.
Yeah. So actually, with AutoML, you don't have access to the underlying libraries like you do with TensorFlow or PyTorch. With AutoML, all you have to do is choose the field. So I actually have it pulled right here. Let me share it with you. You choose the field. Is this a text NLP setup? Is this computer vision? Is this structured data? So once you choose that,
are you sharing an application here? You going to?
I shared the link. Let me share my screen as well.
Yeah, that's good.
Yep. So, and this is a list that also keeps expanding. So if you're doing computer vision, or if you're doing natural language processing or translation, or if you're doing structured data, let's say NLP, for example, then all you have to do is you don't select the model itself. So you provide the data and you provide what is the underlying problem, and this platform does the model selection and the model training and the model evaluation for you. And there's some I was hoping to find a demo here. Maybe we can try it out, but
Are you able to increase the text size a bit?
Yeah.
That's good.
so for example, if you're trying to classify maybe reviews from your restaurant, or if you're trying to classify some other text into one of specific labels, then you can specify that in the beginning. You can provide the data. The tool itself would figure out the best classification model in this case, and it will use one of those models to do the labeling for you. But you don't have access to, okay, I want this model and I want the pre-trained, for example, on Google News, or I want to pre-train on Wikipedia, and you do the classification for me.
So it's black box for us, like what is happening in backend, like how it is getting the best model fit from the data we have given to it.
Yeah, it's supposed to be a service. So if you're usually like a software developer, I mean, you can be a data scientist as well, but if you don't have any modeling interest or background, this is something that you can use as a service.
And one more thing, like as you told that this all is in the Google Cloud. But what if I want to use AutoML in my local machine or my local's own server, except apart from using cloud? So is there any way out there we can implement it?
I think this is a service that runs on the cloud. I don't think there's a package out there that that does it for you. The closest one I can think of is other providers like Data Robot or H2O. So those are similar to AutoML, especially H2O, where you provide the data, you provide what is your field. This is a text, vision, translation, and you provide the labels. And it does not only picks the best model, it actually tries multiple models at a time.
Okay.
And it picks the one that gives you the best performance.
Okay, that's great.
I think H2O runs either on AWS or GCP in the backend, but it's a service.
Okay.
So we had a comment in the chat from Viraf. I'm going to go ahead and promote you to panelist, and you can then ask your question or make your comment directly. So let's see, is that working? You're a panelist. You would need to unmute and start your video if you wish.
Hey, George.
Hi, Ralph.
Yeah, so I was just pointing out, I think it really depends on how one defines AutoML. There are lots of tools out there, so if the AutoML by definition has a set of tools that you give it raw data, maybe specify some parameters, and it tries a number of models and produces one. There's several of them. I named a few in my chat. AutoGluon, Uber's Ludwig, there's PyCaret, there's AutoCaras, like Rahul said. There's a host of them out there. And that was my only comment. And I have used several of them. Several of them are quite good, actually.
Cool. So you have experience with them, okay?
I played with some of them, yes.
So are they very user-friendly? Are they easy to install? Are they easy to navigate?
Yeah, they're like pip install, and then I have great Docker images with Jupyter, and then I just use them.
Awesome, good to know.
Thank you so much. I will explore them.
Are there other people who are still in attendee status who would like to speak briefly about what you are doing yourself on Cloud AI, or for that matter, if you're only thinking about it and you have your situation that you'd like to talk about and get a reaction from George or from others, I'd equally enable you. So, once again, just raise your hand to be called on. Well, not seeing any for the moment. George, let me ask you, You are running a meetup with a series of learning possibilities called Deep Learning Adventures. Would you say a little about what you're doing there? You did one recently that looked very interesting to me, given my own personal focus on sentiment analysis and emotion AI, but I wasn't able to take part in that. Would you say a little bit about what you're doing there?
Yeah, absolutely. Yeah, and I can share my screen again if you don't mind.
Yeah, go ahead.
Yeah, so this whole concept started as a group, as a community. We have this meetup called Deep Learning Adventures, and we started this coding challenge, and the goal really was to use the AI and deep learning knowledge that we've gained for the last 2-3 months, taking a specialization in deep learning, and really tackle some new challenges and new problems, and really be a community and a collaborative hands-on session. So we started with a computer vision problem where we try to identify disease in a cassava plant. It's a plant that's used throughout the world, especially in sub-Saharan Africa. That was an interesting challenge, and that's actually an application that's been developed on an end device where farmers would take a picture of the plant, and based on the image classification model that run on the phone, you'd get to know if your plant is healthy or if it's impacted by one of the multiple diseases that can impact the plant. You can also ask for help for the local farmers. And the other 2 events that we did is NLP related, and specifically I wanted to get a little bit my hands-on on annotating the data first before we take a deeper dive into larger data sets. So we actually looked at the script for a popular TV show, The Big Bang Theory here, and we annotated each sentence into one of 7 categories like joy, sadness, anger, fear, disgust, neutral, and non-neutral. And that's actually an NLP challenge, social NLP, that's been going on for several years, I think. And that was the annotation part. We as a group, the community, we also couldn't agree on labeling each sentence accurately. Is this joy? Is this neutral? Is this non-neutral? And so forth.
I've had experience from that. I've been dealing with that question for 15 years or more. People somehow believe that humans are perfect in terms of understanding what other people are saying, whether it's written or spoken or facial expressions, and that's not at all the case. I go back to a series of academic research papers from 2005, 15 years ago, that found what we might call inter-annotator agreement of 80% typically when it came to sentiment ratings. People do not understand one another. It is anywhere near as or agree anywhere near as much as others imagine.
Yeah, and you could see that in the data. Whenever the annotators, there was 5 annotators for each row in this larger data set. We also, as annotators, we couldn't agree fully, but it's an interesting experience. We also, for the larger data set, for another TV show that we did, Friends, we used already labeled, already trained, already classified data. We didn't label them, and the underlying setup was that 5 annotators annotated each sentence into one of those 7 emotions, and you could see some cases multiple emotions were expressed by these annotators, and the model of the best thing it could do is classify as non-neutral. It's ambiguous, basically.
So here's one for you. I've seen recently a criticism of the TV show Friends that all the characters are white. And people are very concerned about bias, and bias can be introduced in a number of ways. For instance, if you have training data, take Friends, that is not representative of a larger population, and then you apply the models that have been created to the larger population and it doesn't recognize non-white faces. Or for that matter, we introduce bias if everyone who's participating is male, or everyone who's participating is from a certain other type of background. Are you dealing with that here, or are you just doing your exercise?
Yeah, actually, no, absolutely. Fairness and inclusion and diversity, it's part of the journey. And to me, the fairness and the inclusion is actually baked into the data that you're using. So for example, like you mentioned, if you're doing computer vision, you'd see that the regional cast is not representative. But following the news, I've seen that if the show was launched today, it would look completely different. And later on in the show, actually, the director introduced more diversity into the show, so you could see different voices being heard and represented. Yeah, absolutely. That's something that's in the back of my mind, and actually, as a challenge to the community, we can maybe tackle fairness in AI as one of our next coding challenges.
Yeah, Viraf has made a comment in the chat. If you ask someone to annotate the same document a few months apart, you will find differences in annotations. So yeah, there are consistency questions, even if you have the same annotator. But these are things that are the challenges that are known, and I'm sure there are other challenges that are manifesting themselves, but we're not really tuned into them yet, that we're going to have to be dealing with, and maybe correcting our models after the fact to deal with these issues. But once again, let me invite others to, I'm limiting it because of the number of attendees, but to raise your hand, and I will happily enable you to ask a question or talk about your own experiences. I am definitely hoping that people will talk about their own experiences, so please don't hold back. It's a friendly audience. But once again, in the meantime, I'll pose a question to George about his own situation. So I do see that we have logged on one of the regular AI Roundtable participants. I'll name him Jim Fackler, who is a physician, and he is working with medical information. And in particular, he's looking to build solutions that can detect blood infections, sepsis, and so on. You deal, George, at Share Our Strength, No Kid Hungry. Presumably you deal with personal information about minors that might be sensitive, or maybe you don't. But in any case, there is a lot of very sensitive information out there, and some people might be holding back in terms of cloud deployments. How good are the platforms in terms of protecting personal information? And go tackle that one, and then have another one for you as well.
Sure. Yeah. Personal identifiable information is very critical, and as an organization, absolutely, we pay attention to that.
Yeah.
And having said that, all the products that we develop in the cloud or on-premise, we make sure that they are anonymized. There's no personal identifiable information. And I'll mention a service that we actually support as an organization. It's a texting service where families can text the number 877-877. They can text their address, and we will recommend to them 3 nearby sites where they can go and pick up a meal. When we analyze the data and we present it to internal and external stakeholders, there's no personal identifiable information there. We can see demand for the service and for meal sites at state level, county level, at the zip code level. We end the analysis at the zip code level. I mean, internally, we have access to all the data, but we make sure that once the analysis begins, all the personal identifiable information is removed. And even in the worst case, when there's a security breach, then even that worst case, then there's nothing there to be found.
Yeah.
I see another question from Frederick.
Yeah, I see. Where do you see that? I see Roman. I'm going to enable Roman. Who do you see here?
From the chat, Frederick Abramson.
Oh, I'm sorry, I missed that one. Okay, Roman, I've enabled you, and I will enable Frederick so that he can speak after this.
Perfect, thank you. Hi guys, my name is Roman. I'm not sure how related my question would be, but since you mentioned ONNX pretty much format, and that's one thing. One of the challenges that I'm facing now is pretty much finding a way to export my model and pretty much use it later on for further predictions. And there are a lot of tools that are allowing, even Keras allows you to dump the model, to save model and load it later on. However, pretty often you need to normalize your features, do various normalizations or scale or tokenization. So have you guys run into any best practices on how to pretty much bundle it together with your model so that when you do predictions, that normalization would be happening on the model side rather than sharing the state of normalization beforehand?
That's a very good question. And actually that's the heavy part, right? So there's a research done that 80% of the time from a data scientist perspective is spent on data collection, data preparation. 20% is actually spent on building the model and deploying it. Actually,
I've been in this industry for a long time, and we've been talking about that for as long as I've been doing this.
I hope it's changed because it's a very unequal distribution. But actually, this deep learning framework, especially TensorFlow that I've personally worked with, and as well as PyTorch, you can actually embed the pre-processing step, what is called as a layer of your model. So if you're doing some heavy pre-processing, some image featuring, some image extraction, some feature extraction, normalization, whatever it is, you can actually embed that as a layer to your model. And that will be the first thing that a model will do before it even runs the next few other layers. So you can embed it, you can export it, and you can run it anywhere you want.
So even tokenization and feature scaling can also be run as, as a layer?
Call a custom layer. Yeah, you can introduce your own custom layer. You can do all this pre-processing for you.
Interesting. Okay. Yeah, I'll check it out. Thank you.
Yep.
And Frederick?
Thank you, Seth and George. For context, those listening, I was doing expert systems AI decision support in the 70s and 80s, in the old days before computers could be spelled by most people. But clearly the technologies move way beyond me. My experience has been almost exclusively in healthcare and in providing solutions built around data that provides good predictability. I'm interested in finding collaborators because I have a startup to build a mobile platform that uses AI to look at genetics, nutrition, and other individual data to predict wellness outcomes. And then on an ongoing basis in real time, help them shape their behavior where their personal data combined with genetic data gives them insight into decisions they make. This is a model that no one's really using because they tend to be report driven. Here's the report, here's the 30 pages and go read. But from my technology background, the dynamics of AI, of mobile systems combined with the analytic power of AI deep learning means as a tool. I'm not the guy to be writing this stuff, but I am interested in collaborators who might want to get involved in this. So that's my statement. And thank you for Seth and George for allowing me to say this.
Well, Frederick, I'd be happy to put something out if you can send me something in writing either via the Meetup platform, or I gave my email address if you kept it early on. And for that matter, I'll give people my email address again because we will have future meetups and we can always use speakers, not just on the topic today, of course, but anything related to AI technologies. So send me something.
I shall. I appreciate that, and thank you so much.
It's very close to another project that our organization we're going to tackle. It's related to social determinants of health, where basically where you live, how far you are from a bus stop, how far you are from a nearby medical facility, what is your health insurance, basically where you are and what you do in the world really impacts your way of life and your health. So I'd be also super interested in learning more about it, your idea, Frederick, but it's very interesting. You're proactive in recommending something, not just reporting, but recommending something to improve an outcome for a user.
You said something very important, George, which is world. The approach we have to use is one that could be used anywhere in the world because everyone has genetics, has genes, yep. Everybody eats and does things, but we're all different. So we have to have this adaptable to anyone, no matter where they are, as opposed to just a US-centric model. So I'll sign off now. I'll mute myself.
So Frederick, though, feel free to put your information into the chat so that people can see it.
I'll do that. Thank you very much. I appreciate that.
Okay, very good. I'm going to switch you back. And I've enabled Shelley, who's one of our AI Roundtable regulars since the beginning, who has a request.
Hi there, George. Question, often in the Roundtable, we share best practices. I'm really interested, based on your experience, about maybe what we call worst practices. What are sort of the common mistakes, common errors, common bottlenecks that you see, especially with regard to implementing and scaling up solutions and working with AI within product development?
Yeah, that's a good question. Actually, to me, the most important part is recognizing that, as a data scientist, you don't just have technical obligations to your model, especially if it's publicly facing. You also have, you know, ethical obligations, moral obligations. So we touched a little bit about this, but for example, representation and fairness and bias in your model, at least you should be aware of that. At least you should know that your entire training data set, it's only pictures of a specific person of a specific background, that later on when you deploy it and maybe it's used in a real world application, that you should know its limitations and you should know in advance what can it do, what cannot do. There's a lot of news in the past, I don't know if you've seen it, but a lot of companies like Amazon and other ones were using AI models to screen employees as they were applying for a job, and they saw that it was heavily biased towards, I think, men, specific white men. So they scrapped the whole project apart because their entire training data set was probably based on specific backgrounds. So at least the knowledge of the data and how representative it is of your customer base, it's very important.
Well, the problem there is that you build models that are going to give you more of the same. If your current roster of engineers is 80% male, then the models that you build with them could be at least 80% male, if not more, because there's a much heavier and outsized weighting of the characteristics of those male, and that can perpetuate any number of kinds of issues. I'm going to call for folks once again to participate. Don't let me down here. So please raise your hand if you want to be enabled. And in the meantime, I have yet another question for you, George, which is I did take a look at the resource that you provided a bit earlier, ONNX.ai, which was about model interchange. And of course, we have a different sorts of interchange in this world. We have processes that tie together models. We have the kind of data provisioning that you were talking about just a few minutes ago. We might have things on the output side of the models. Are there any kind of interoperability standards under development that will address the whole rest of things, not just the model interchange, but to promote greater interoperability of all these platforms? Do we still have you online, George?
Yeah. Sorry.
Are there efforts to promote greater interoperability in all of the areas that surround models?
Yeah, so apart from the project that I mentioned, I'm not aware of other ones. Usually open source projects have this idea of collaboration and bringing ideas from different backgrounds. But I'm not fully or actively aware of other research projects that actually enabled that.
So I'm going to make a final call for people who wish to be enabled to participate to do that now. But let me ask you a sort of summative question or a forward-looking question, I should say. Where do you see all of this going? Do you have a crystal ball yourself, or are you just trying to stay on top of all of the possibilities that are emerging?
So for me, usually, I don't have a crystal ball. Usually, for me, it's
federated, for instance, possibilities. It's more of that.
It's interesting to hear like leaders, like CEOs, of what is their vision and where things are going. So yeah, the one that I mentioned, for example, with the interview that I had with Lawrence Moroney, as well as another one that I have in my mind with Tesla, for example, and self-driving cars and Waymo.
Right.
This entire rich ecosystem that, you know, Waymo has billions of miles, or Tesla has billions of miles, but they're all trained in nice weather, sunny West Coast weather, where the roads are beautiful and there's no rain or snow, no weird bridges. So taking that and actually scaling it out to different regions of the world, where you can actually expose your model to different situations that you never see on one part of the world. That's what, like, one vector thought for me. And that's more of like, okay, we've done something in this part of the world, we have to make sure that it works other parts of the world. That means that you have to retrain it from scratch, basically. It's a completely different environment.
Well, that's a big topic in the areas that I look most at, natural language processing, where there's a huge amount of work that's been done in English, a lot of resources available in English. Then there's the second tier of languages that include Chinese, but also mostly European languages after that. And then there is a whole ocean of less resourced languages. Resourced meaning models that have been built, but also old style engineered rules, taxonomies, ontologies, word networks, all of that kind of stuff. So I do focus on language, but my assumption is that that's true for all sorts of other data types and challenges.
Yeah, absolutely it is. Yeah, and all this, speaking of NLP, all these different data sets, all these different brand new transformer-based models, they've been trained on Google News, Wikipedia, mainly in English. Like it's very challenging to work well in Spanish or other languages.
Of course, the premise there is that maybe you have a model that's trained for one industry or purpose that is going to be transferable to another domain or industry or perhaps even another language. You know, that the models that are out there are 90%, make up a number, 80%, 90% of the way there, and that the last mile training can be done with a relatively small data set. You know, that is the claim and the hope nowadays.
Yeah, that'd be great. Yeah, I haven't seen it yet.
And you know, the trick is making it work. Okay. Well, do you have any parting remarks for us today? I guess a good thing is you've mentioned a number of authorities whom you follow. Any particular way that you recommend that people learn more here, whether it's through online coursework, what source, through the tutorials that come with these platforms? I mean, you know, the joy of it is that there's a whole lot of stuff out there for free, especially if you're just doing basic learning level stuff. And it's hard to decide where you're going to start because there are so many possibilities out there. But any recommendations or suggestions for people?
Yeah, absolutely. Yeah, online courses, that's the best place to start. For me, once you do that, I personally prefer it when I'm part of a larger community, maybe part of a larger meetup where you can actually collaborate, join meetups.
Well, hence your deep learning adventures.
Hence my deep learning adventures. I think I like the inclusiveness. I like the challenge. I like the motivation that, okay, this week I need to work on my model because on Friday I will talk with my friends. So it's something that keeps me engaged, especially with this pandemic and everybody working from home. It's something that I look forward to each week. Obviously, there's Coursera, there's Udacity, there's edX, there's Udemy. There's so many platforms available. YouTube as well. I have really follow YouTube as well. Twitter, sometimes it's leaders that I mentioned, like they like to post results or different updates, very active. But again, for me, I like the closeness and the community feeling when tackling either theoretical model or maybe a hands-on coding session.
So Irene Castillo asks, what courses do you recommend, Georgia? Anything in particular?
Yeah, so
if you're doing NLP, for instance, I might send you to Stanford NLP. It's an academic setting and all of that kind of stuff. But that kind of thing, you know, an academic coursework like from Stanford gives you a very solid grounding in the field. It's not just a matter of some cookbook. It helps you understand the concepts as well as the practices.
Yeah, for sure you need some basic math, basic calculus, basic linear algebra. You need that as a foundation to start any analysis, regardless of the field that you're tackling. Then it would be great if you have some, or if you can build some programming experience. Pick any language that you prefer. The more user-friendly to you, the better. That combination of basic, again, math and programming, I think you're a very good setup to start tackling a new challenge. Again, you have to be open-minded. You have to be willing to learn new things. This is a new concept for many of us. Again, this field didn't exist, you know, decades ago. It's some of this state-of-the-art architectures that you see right now that were like developed 6 months ago or the latest 3 months ago. So it's a constantly evolving field. So even if you feel that you know, you haven't touched these things for a while, you still can get in. There's no perfect time.
I enabled someone else here, Haitham El-Kuidi. Sorry if I got that pronunciation wrong. If you're willing, you can unmute and pose your comments and questions yourselves. yourself rather. By the way, I came into the technology world from studying math and applied math in particular, and I had a great job several decades ago working at NASA on satellite simulations, and we were doing this maximum likelihood estimation, and we were doing filters, stochastic processes, and so on, optimization methods, steepest descent, and all of that kind of stuff. And it's funny to see those being applied for neural networks nowadays. I said it's funny, but it makes a lot of sense. So it's kind of ironic in my personal case. Hi, Sam, are you online, and do you want to, I can ask your questions for you. Okay, but I guess he or she is asking about, you do recommend learning linear algebra, math, programming, and Python. You said any language, Python or R would be the obvious choices there before getting into AI and ML. I'm going to add to that question. You can do it before, or you can do it during.
Do you mean the sequence?
Well, I mean, you learn both simultaneously. You learn Python programming at the same time you're learning linear algebra, or R would be a better choice in that case, I might think, because it's better suited to handling mathematical objects, at least in my experience. But you learn them both at the same time.
You could, yeah. And the way actually that some people do it is they learn linear algebra and they actually apply it in Python itself.
Right.
That's the way of doing it. You can visualize vectors, you can visualize transformations, you can visualize different algorithms within your keyboard. Usually people do it one at a time, but again, if that's the strength that you have, absolutely go for it.
Yeah. Well, Python, it's very simple to do that you choose what environment you want to program in, and you do hello world, and you learn how to use basic data structures, and there you go. So Haitham had another question. This is a really fundamental type of thing. How are AI, machine learning, and deep learning related? You want to tackle that one?
Actually, my roommate asked me this question yesterday. I think there's a bit of historical context here. Usually when you hear of AI, it's the broadest term of building systems that try to mimic human behavior. Like, that's the most basic and broad definition I can give. It has theoretical aspect to it. It has research that has nothing to do probably with machines. It has research from, I don't know, 20s, 30s, maybe even longer than that. And the machine learning part, to me, it's a subset of it. It specifically deals with coding and computers and using statistical software to actually solve a problem. Deep learning is even a smaller subset of machine learning within AI, where you use a specific model that is made of multiple layers, and each layer is responsible for extracting different features from your data. And it's called deep because these models now can get deeper and larger, and they can basically abstract more and more advanced features from your data. I'm thinking of putting maybe a diagram where you can find different applications of something that is in AI but not ML, or in ML but not DL, and all that. Like, that'd be a nice, interesting Venn diagram.
I'll give you an example. Arguably, creating a linear regression is machine learning. It is inferring a model from the data. And it depends on your definition of the word machine. But, if you could call someone a human computer from World War II who is calculating ballistics trajectories by hand, then a machine doesn't necessarily mean something that is based on a silicon chip, or for that matter, some other automated calculating method. So arguably, a linear regression is machine learning. It is the application of a systematic analytical method to data to create a model. Rather, I guess it applies a model, but that allows you to do, in the case of continuous variables, a projection or whatever. So, that's not deep, and it's also not AI. It's more assistive to a human. Yeah. But these are questions that go far beyond what we really should be discussing now. Anyway, I think we'll wrap up there. So I very much appreciate your participating, George. it's great to have you on. If you wish to come back in the future and do some sort of presentation about your work as opposed to talking about the generalities of the platform, you should let me know. And that applies to everyone who is online today. I'm about to type my email address into the chat, and and I would love to have you, anyone who's online, propose a talk for the Maryland AI and Baltimore Tech meetups, a conventional presentation that is, and that can be anything from 10 minutes to 40 or 50 minutes. And so just send me a note by email or via the meetup platform. And I see that George has put in his email address as well in case anyone wants to follow up. So once again, thank you, George, and thank you to everyone who participated today, and we'll post the video pretty soon.
Thank you. Thank you, Shank, for having me. Thank you, everyone, for participating, and hopefully we'll see you soon.
All right, bye-bye.
Bye-bye.